In this video, we would be discussing about the thermodynamic equilibrium, the state of a system, the property of a system, and the different types of properties. So let us begin with the thermodynamic equilibrium. See, when we take thermodynamic equilibrium, a system is said to be in thermodynamic equilibrium when it is in mechanical equilibrium, thermal equilibrium, and chemical equilibrium. So, when it comes to mechanical equilibrium, the system is said to be in mechanical equilibrium if the net effect of forces or pressure acting on the system will be equal to zero. So, in this particular case, we can say that the system is said to be in mechanical equilibrium. So when it comes to thermal equilibrium, a system is said to be in thermal equilibrium when the temperature remains constant so when it comes to chemical equilibrium, a system is said to be in chemical equilibrium when there is no chemical reaction taking place. So there should be no chemical reaction. So if a chemical reaction takes place, we know that heat may be liberated or heat may be absorbed during the chemical reaction, and as a result of that the system cannot be in thermodynamic equilibrium. So this is about thermodynamic equilibrium. Now let us discuss about the state of the system. So state of the system is nothing but the condition in which the system exists. So there might be a liquid state, solid state, or gaseous state. Or suppose if we take the gaseous state, so in this gaseous state only, depending upon the properties, we can say in which condition the gas is existing. So this is about the state of the system. Now let us discuss about the property. See, this property defines the state of the system. So state of the system means it is nothing but the condition of the system, and condition of the system can be defined by the properties. Now, when it comes to types of properties, there are two different types of properties. The first one is intensive or intrinsic property, and second one is the extensive or extrinsic property. Now, let us discuss in detail about this intensive property. So, a property which is independent of the size or extent of the system is called intensive property. So this intensive property is independent of size or extent of the system. That means this intensive property is also independent of mass of the system. So a property which is independent of mass of the system can also be called an intensive property. Then extensive property, so this property depends on mass or extent of the system. So a property which is dependent on mass or extent of the system can be called as an extensive property. Now let us see what are intensive properties and what are extensive properties by taking a small example. So let me consider there is a vessel like this in which certain amount of gas is present. Now this gas has got certain properties, like this has got some pressure P, volume V and temperature T. And we know that internal energy is a function of temperature. So we can write internal energy also as a property. Then we know that enthalpy is a function of pressure and temperature. So enthalpy can also be considered as a property of the system. Now see, the formula for change in internal energy U2 minus U1 is mCV T2 minus T1, whereas the formula for change in enthalpy is mCp T2 minus T1. Now suppose, let me consider that I have placed just a partition in between this vessel. So when we have placed a partition in between this vessel, the pressure in this chamber and in this chamber will be the same. The temperature in this chamber and in this chamber will be the same, whereas the volume in this chamber will be different and in this chamber will be different. So let us say volume in this chamber is V1 and volume in this chamber is V2. So the total volume is V1 plus V2. That means here volume is depending upon the size of the system, and if you observe, the internal energy is dependent on mass of the system and enthalpy is also dependent on the mass of the system. So therefore the internal energy in this chamber will be different and enthalpy in this chamber will be different. So if we write intensive properties, intensive pressure and temperature are intensive properties, whereas when we consider extensive properties, we can take volume, internal energy and enthalpy as extensive properties. They are dependent on mass or extent of the system. So This is the major difference between intensive properties and extensive property. Now, any extensive property divided by mass will give an intensive property. For example, you can take specific volume, small v, which is volume by mass. This is an intensive property. Specific internal energy, which is denoted by small u, which is capital U by F, and specific enthalpy, small h, which is total enthalpy by mass. So any extensive property divided by mass will give us an intensive property. That's why specific volume, specific internal energy, and specific enthalpy cube per kg. Specific volume has unit of meter cube per kg, whereas volume has an unit of meter cube. Then specific internal energy has an unit of kilojoule per kg or joule per kg, whereas the internal energy has a unit of kilojoules or joules. Specific enthalpy has a unit of kilojoule per kg or joule per kg. So this is about the different types of properties that we have.